Hi, my name is Samir Mishra, and this is my video for the extra credit lecture. So, I went to two lectures, with the first lecture being um, Baby Galaxies, the First Steps Towards Creating the Milky Ways by John Wise. And it was basically about the creation of the galaxy. But there, in the second lecture I went to was the Nepomuk Ott's Cosmic Rays. And I actually found the Cosmic Rays lecture much more interesting than the other one, even though I was expecting the other one to be much more interesting, at least to me. So the reason I went to the Cosmic Rays one was because, um, honestly, I didn't know anything about it. It just sounded kind of cool, and it's Cosmic Rays, like it sounds cool. So I decided to go and see what it's all about. And so the guy who presenting it, Nepomuk Ott, a German guy, he was cool. He explained a lot of it. So basically, cosmic rays are high energy particles generally originating from outside the solar system, or at least outside Earth. So from things like stars, black holes, gamma ray bursts, and pulsars. And he basically went over a lot of the different kinds and how like they're portrayed in like graphs and things like that. So he talked about a lot how they actually like affect us, which I thought was really interesting. So for example, they contribute to natural radioactivity. Apparently, I looked this up, and every human is exposed to a certain amount of radiation. He kind of went over this, but not in that much detail, I think. He talked about how every human is affected or exposed to a certain amount of radiation due to these cosmic rays. And something I found extremely interesting was how airplane crews, who generally are up and more in the atmosphere, are exposed to almost twice as much. Because the thing about these cosmic rays is that they often penetrate through the atmosphere, but they don't make it often that far, which is why people on the ground are usually okay. But since airplane crews are up in the atmosphere, they get much more exposure from cosmic rays. So they're at least more in danger for radiation. I don't think it's deadly, but if you fly a lot, watch out, I guess. And another thing about cosmic rays is honestly they do a lot of they do a lot of quite kind of bad things. They affect the functionality of highly integrated electronics. So, for example, they can cause a lot of corrupted data. And I looked up other things about cosmic rays, and apparently they potentially credited the failure or malfunction on the Voyager 2 probe back in 2010 to cosmic rays because it flipped a bit or something like that. So I found that interesting. And they also credited it to be possible seeds for lightning, as in they're possibly behind the reason why the sparks start and something like that. And he went over a lot on measuring it, and he's talking about how they have these things under ice in or Antarctica or North Pole, I think, basically under ice, and these things would measure it. And there's this thing called the Cherenkov telescope array, with over 50 different telescopes to measure these cosmic rays. So yeah, honestly, this was really interesting. I had no idea what cosmic rays did, and while they don't seem like good, they're definitely really important. And another interesting thing is, apparently they're the greatest single barrier to space travel. Because in order to account for it, you have to take a great deal of shielding into account when you're going into space and things like that. Because otherwise, the people and the electronics will be greatly damaged. So that was the cosmic rays lecture. The other lecture, which was the Milky Way one, or Baby Galaxies, the First Steps, it was on the creation of galaxy. I found it interesting, but at the same time, I thought the cosmic rays was more interesting. He started by describing like the Big Bang and different galaxies, and he described the history of the universe, which I thought was really cool, using like different layers. So basically, he started with like the big, I guess the small, like little beginning of the universe, the Big Bang thing, and then you go down and you see like different things form from like the gases and the materials. So I thought that was really interesting. The most interesting thing I saw in there was this one animation, I think from Japan, that showed how time progresses in the universe as when you're far away. So, for example, a man who sees like a baby while he's 80 light years away, the girl still grows, the baby still grows. So by the time he sees the baby, it's actually a grandmother type figure at the end of at the end of the telescope, because he's so far away. That's how far light travels. All right, and I think that's about it for me. I had a great time with these lectures. Thank you.